Old star maps may be quite beautiful, but they do not represent the real sky very accurately. They show only the brightest stars. Star maps from the last century show fainter stars thanks to better instruments. This is a sky field in the southern constellation of Centaurus. The same field was photographed with the ESO telescope. This globular star cluster is called Omega Centauri. It contains many millions of stars very close together. Look at the small area at the very center of Omega Centauri. On the Schmidt photograph, we see only a few fuzzy stellar images in this area. This photo is one of the best ones obtained with the ESO 3.6-meter telescope. It has sharper images and higher resolution, and we see more details. But ESO's new technology telescope is even better. Its images are almost 3 times sharper. We see many more details. We can sharpen the NTT images further by image processing. Now they are almost as sharp as if the NTT were in space. Sharper images mean that we can see fainter images. It's just like focusing the telescope. The fainter the objects a telescope can observe, the further we can look out into the universe. This is a 2-hour exposure from the ESO Schmidt telescope. A very faint and distant globular cluster was discovered on it. The NTT photo shows much more detail and also fainter stars. The exposure time was only 10 minutes. This rather bright star has magnitude 18, and this faint one has magnitude 25. It is 40 million times fainter than what can be seen with the unaided eye. The NTT can observe fainter objects than any other ground-based telescope. There are many beautiful nebulae in the Milky Way. They shine in many colors. This is the Rim Nebula. And this is the bright Omega Nebula. Stars are born in nebulae like these, as well as in the large Orion Nebula, which has a very complex structure. There are strangely formed small nebulae near some stellar birthplaces. From some of the infant stars, jets of fast-moving material stream outwards. The nebulae are found where these jets ram into the surrounding interstellar material. Now, some high-resolution NTT photos of these nebulae. They are called Herbig-Haro objects, and they shine in the light of highly excited atoms. Other nebulae in the Milky Way have more regular forms. These are the so-called planetary nebulae. They come from dying stars that throw off their outer layers, which then form nebulae around them. Some of these nebulae are very beautiful, and some have rather peculiar shapes. This is the famous Crab Nebula, photographed by the NTT in different colors. It is the remains of a star that exploded as a supernova in the year 1054. In this infrared image, we can easily see the famous pulsar at the center. The Large Magellanic Cloud is a satellite galaxy to our Milky Way galaxy. It contains a number of nebulae that shine in ultraviolet light. They are remnants of supernova explosions long ago. The NTT image shows the beautiful filamentary structure of this one. Another one looks like a swan, and this one has 2 narrow loops. This is an NTT photo of the light echo around supernova 1987A. The supernova appears to have blazed a trail through the interstellar matter, and the nebula around it now looks like Napoleon's hat. At the very center, there is an oval nebula, only 2.5 arcseconds across. It consists of matter lost by the star before the supernova explosion. The good resolution of the NTT now makes it possible for us to see it. Not very far away from the supernova is the Large Tarantula Nebula. This is an NTT photo showing the very complex structure near its center. And this is the central stellar cluster. The Fornax dwarf galaxy is almost 700,000 light-years away. It is the only known dwarf galaxy with globular clusters. The NTT picture of this cluster clearly shows the individual stars for the first time. Now we can begin a detailed study of them. Other dwarf galaxies are more irregular. The NTT also shows individual stars and nebulae within them. NGC 300 is a large spiral galaxy about 10 million light-years away. It looks like the Milky Way, the galaxy we live in. With the NTT, we can observe the stars in this galaxy and also the detailed structure of its many nebulae. This is the center of another galaxy, NGC 1365, about 65 million light-years away. This NTT view of the inner regions of NGC 1808 gives us an impression of the violent motion in this very active galaxy. There are many luminous knots at the center. Some galaxies have wide dust lanes. This is not the famous Sombrero galaxy, but NGC 681, which is much smaller and fainter. NGC 2992 is also quite dusty, and so is the beautiful spiral NGC 613 and the barred galaxy NGC 6300. This huge pinwheel is the famous NGC 1068 of the active Seyfert type. And this small group of strange-looking galaxies was first found at ESO some years ago. The NTT enables us to see in great detail how gravitational interaction has distorted them. Distant clusters of galaxies will be one of the NTT's main observing fields in the future. The first test observations have fully confirmed its ability to provide sharp images of faint galaxies in even very distant clusters many thousands of millions of light-years away. The quasars are even further out in space. Some of them, like this one called the Einstein cross, have multiple images very close to each other. Here you can see 4 images of the same quasar. This is what's known as gravitational lensing. On this short exposure NTT image, we can see the lensing galaxy that split the quasar light and also the 4 quasar images in the middle. From technically simple, easy-to-use instruments, we have advanced to extremely complex computer-controlled telescopes like the NTT. Observations from the control room have already begun with this new telescope. The NTT opens new horizons for Europe's astronomers, and during the coming years, the NTT will provide them with new, exciting discoveries. With the NTT, they will be ready to make the best possible use of ESO's next super telescope, the 16-meter Very Large Telescope.